Hello, my name is Jason Dukoff, and I'm a professor of agronomy and soil science at Tennessee State University. This is the second module in my drone certification training, or Part 107 certification training. And this one is going to focus on the aircraft itself and some of the different types of forces that you'll find on an aircraft. And so to start off with, we'll focus on some of the different axes of rotation and some of the nomenclature that goes along with that. So the first one is the longitudinal axis, and you can see that that runs through the plane from the tip of the plane, the nose of the plane to the tail. And so rotation about this axis is called a roll, and it's modified by the ailerons. And then our next axis is the lateral axis, and this runs through the wing of the plane. And any sort of rotation about this axis is called pitch, and it's modified by the stabilator or the elevator. And then the last axis of rotation is the vertical axis, which runs directly through the aircraft from top to bottom through the very center. And rotation around this axis is called yaw, and it is modified by the rudder. Now, this is a cross section of a plane wing, also called an airfoil. And we're using this to demonstrate how we create lift on an aircraft. And so running through the cross section, you see what's called a chord line, and that runs essentially from the front of the wing all the way to the back. And this angle that's created by the chord line is really important as it relates to lift. Also, the angle of air is going to be important. And you can see in this case, the air is running smoothly along the surface of the wing, and that's what we want to see happen. The air is going to be pushing up against the front of the wing, and that's what's going to be helping to create lift. And actually, it's the angle, also called the angle of attack, between the chord line that you see here. So the black line on this angle relates to the same angle as the chord line. And then the blue line on this angle of attack relates to the same lines of the air as it flows. And so essentially, as the angle increases, the lift is going to increase. Now, at a certain point, however, if the angle gets too large, we can have a situation occur where we have a stall. And so this is an example of that. So you can see the chord line has a much greater slope to it. And when we put that against the same slope of air movement, we're going to have a much greater angle. And so that angle is so large that the air can't move right along the surface of the wing anymore. And so it kind of gets broken up and it creates these things called burbles or turbulence. And so that causes the stalling of the aircraft. Now, these are the four different forces on an aircraft. We've got lift, which we just talked about. That's keeping the aircraft up in the sky, and that's counterbalanced by the weight of the aircraft. And then we've got the thrust, which moves it forward, and the drag, which holds it back. It's kind of like the friction on the aircraft itself. Now, when there's no acceleration, when we've got essentially straight level flight, the lift is going to equal the weight, and the thrust is going to equal the drag. Now, load factor is a question that comes up on the exam, and it is related essentially to the differences that occur between lift and weight. And so when we're engaged in straight level flight, our lift, like I said, lift is going to equal weight, and that's going to give us a load factor of 1. Now, when we bank or when we turn, some of that lift force is going to be converted into a horizontal motion. And so that lift is actually going to decrease because part of it is now horizontal force. And so as you can see here, we've got a 45-degree bank. We've got a lift now that is less than our weight. And so we're going to start descending because the weight is essentially larger now than the lift. And so the question is going to be, what is the the load factor. So if we want to maintain altitude, we're going to have to apply a greater force to increase that lift. And so what's the load factor? What's that new load factor going to be now? And so luckily they give you these handy dandy charts. And so to answer that question, you just have to look it up on this table. And so we said in the previous slide that we were engaging at a 45-degree bank. So we can look at this table and we can read it right off the table. So our new load factor now is going to be 1.414. And so this load factor, we also relate it to G units. So we're familiar with G's when we're talking about a rocket ship or a roller coaster. You know, that's kind of the force that's kind of pushing you back in your seat. And so sometimes there might be a question that that takes an additional step, I guess you could say, where they want to know, you know, what's the new once all this has happened, what's the new kind of force that's being applied, or the new effective weight of the aircraft. And so, like I said, we had to accelerate in order to maintain altitude, and so that created some G's. And so we've identified that change that was from 1 to 1.414. And so now sometimes if you were on the aircraft and you were sitting on a scale, your weight would essentially increase as you're being pushed back into your seat. And so it's the same sort of concept when they ask that question, what's the new effective weight, or what's the new additional force that's being applied, some of those types of things. So they will give you the initial weight of the aircraft. So let's say in our example, the weight of the aircraft is 10 pounds, okay? And so under this situation where we had a 45-degree bank, we increased the load factor. What we would do then is we would multiply that 10 pounds by the new load factor, which is 1.414. And so our new effective weight of the aircraft is going to be 14.14 pounds, because we've applied that additional thrust, that additional force, which pushes us back into our seat. So that's just how to answer some of those load factor questions that you'll find on the Part 107 exam. Now, the last thing I'm going to go over is some of the regulations with respect to flying over people, because they're related a little bit to some of the energy that are created by different aircraft. So for a Category 1, this is limited to drones with a maximum weight of 0.55 pounds. In this case, you can fly over non-participating people as long as the aircraft does not contain any exposed rotating parts that can cause lacerations, and it does not contain any sort of safety defects. So as far as the lacerations go and the exposed rotating parts, a lot of drones will come with some type of a cage that can help to cover the blades, the propellers of the aircraft. And so you would want to have those if you're flying over non-participating people with this size of a drone. Now, with Category 2 or 3 drones, these are going to be larger drones. The specific definition for a Category 2 drone is that it will not cause injury to a human being that is equivalent to or greater than 11 foot-pounds of kinetic energy. Now, for Category 3, it's essentially the same thing except it's a larger drone. So in this case, Category 3 will not cause injury to a human being that is equivalent to or greater than 25 foot-pounds of kinetic energy. So those are the differences between Categories 2 and 3. And so also, of course, with those aircraft, you also need to make sure that there's no exposed rotating parts that can cause lacerations. Also, those aircraft have to have a declaration of compliance. And so the manufacturers actually submit a declaration of compliance to the FAA. And the drone has to be labeled by the manufacturer that identifies that it has that compliance. And so now with category 3, we also have an additional factor where flying a category 3 drone has to be done in a closed or a restricted access site where everyone is aware that a drone's being flown over them. Or if you're not in one of these sites, the pilot has to make sure that there's no sustained flight over a non-participant. Okay, so that's for category 3. Now then, category 4, of course, we're talking about an even larger drone, and these are going to be limited to drones with an FAA-issued airworthy certificate. So this goes beyond that declaration of compliance that I talked about, and of course, this is all required for the manufacturer to get that airworthy certificate from the FAA. And again, the drone has to be labeled this way by the manufacturer itself. And so the last thing here is that any sort of an open air assembly where you've got a number of people in a crowd, that is restricted to category 1, 2, or 4 drones that meet the remote ID requirements. So remote ID is a new thing that drones are going to come equipped with a remote ID, which is essentially going to broadcast a signal. Essentially, it's going to be like a license plate. So that signal is going to identify different things like the owner and the registration number. And so it's going to be a lot more regulated in these situations, especially when you're dealing with a lot of people that the drone's going to be flying over. So people are going to know who owns that drone and some of the different specifications related to that. Okay, that finishes up this module related to some of the different forces on an aircraft and, of course, the regulations on flying over people. This is my contact information. Feel free to reach out to me if you have any questions. And then our next module is going to be focused on physiological factors and risk management.